All right, let's get right into it. Today, we're digging into a piece of tech that tries to answer maybe the biggest question in the entire crypto space. Can a blockchain actually scale to handle the whole world's data? The project we're looking at is called Teranode, and its goals are, well, they're absolutely massive.
So let's really think about this for a second. The promise of blockchain has always been world-changing, right? But there's this one massive roadblock. How do you get a network that's supposed to be decentralized to handle the insane volume of transactions that something like Visa or the internet itself just chews through every single second? Most of them don't even come close.
Okay, and this right here is where things get wild. Just look at these numbers. Bitcoin, it manages about 7 transactions per second. Ethereum does a little better, around 30. But Teranode, the system we're digging into today, is being built to handle over 1 million transactions per second. That's not just an improvement, it is a completely different league.
So what's the big holdup for most blockchains? Well, you can think of them like a single-lane country road. If you've only got a few cars, no problem. Everything's flowing just fine. But the second you get a rush of traffic, you've got a massive jam. For a blockchain, that traffic jam means super slow confirmation times and fees that can go through the roof.
You know, what's really interesting is that this bottleneck, it isn't always some kind of accident. For some networks, it's actually a feature, not a bug. They've made a choice to prioritize what they call extreme decentralization, the idea that anyone can run a full node on a basic laptop. But that choice comes with a huge trade-off. You have to sacrifice serious speed and capacity.
And that's exactly where Teranode comes in. This isn't just another small update or patch. It's a fundamental redesign of how a blockchain node even works. The whole idea was to stop thinking in terms of those small country roads and start building an engine that's powerful enough for a global superhighway. The secret sauce here is the jump from a monolithic design to something called microservices. So picture a single chef in a huge, busy restaurant trying to do everything, taking orders, prepping the food, cooking it, plating it all by himself. That's a monolithic node. Teranode, on the other hand, is like having a full kitchen staff. You've got one person chopping veggies, another one at the grill, someone else plating the food. Every service is specialized, and they're all working at the same time, in parallel. That's how you get to massive, massive scale.
So what does the transactions journey look like in this new system? Well, it doesn't get stuck in a queue waiting for one overworked process to handle everything. Instead, it flows down this kind of digital assembly line. It hits a specialized microservice for submission, then gets passed to another for validation, then another for assembly into a block. It's this super efficient division of labor that really unlocks that incredible speed.
But listen, having a monster engine is one thing, but it's useless if you don't have the wheels, the chassis, and the steering to make it go. Teranode is built to use 4 other key technologies that all have to work together to make this global system actually function.
So let's take a quick look at this toolkit. There are 4 pillars holding this whole thing up. First, you've got SPV, which is just a way to let you verify transactions on your phone. Then there's IPv6, the internet's modern address book, which allows for direct peer-to-peer pathways. After that is multicast, which is a really smart way to deliver big chunks of data to a lot of places at once without creating a network traffic jam. And finally, you have IoT, the Internet of Things, which is all about letting our smart devices, from cars to coffee makers, talk to each other securely on the network.
Let's start with SPV. Now, this is a pretty genius idea that actually comes from the original Bitcoin white paper. It's what allows you to securely check a transaction on your phone without needing to download hundreds of gigabytes of the entire blockchain history. This is absolutely critical if you want billions of people to actually be able to use the network on their everyday devices. Next up is IPv6, the Internet's modern addressing system. By building this in, the system allows for direct peer-to-peer transactions, just like how Bitcoin was first described. This is huge because it cuts out a lot of the middlemen and gives us a practically infinite number of unique addresses. We're talking one for every single person and every single device on the entire planet.
Okay, so we've got this super powerful engine with Teranode, and we have these 4 supporting pillars. But how do they actually come together to create something totally new? This is where we connect the dots.
And here's the beautiful part, how it all syncs up. Teranode is the engine, right? It provides all that raw number-crunching power. IPv6 is what builds the actual global highways for communication. Multicast accesses the super-efficient delivery service that runs on those highways. And SPV? That's what secures all the on-ramps and off-ramps, our phones, our computers, and all those IoT devices. So when you start putting all these pieces of the puzzle together, you realize that the goal here is so much bigger than just making faster payments. The ultimate vision is to create what's being called a true Internet of Value.
And this quote right here, it just perfectly captures the whole idea. It's not about building a new financial system. It's about building a single, global source of truth for all kinds of data, where literally every interaction from a financial transaction to a supply chain update can be locked in as a secure and verifiable transaction.
So let's bring it back to this performance chart, but now we have all the context. Look at that cost per transaction, less than 1/100th of a cent. This is where you have to shift your thinking. This kind of system isn't really designed for speculating on assets. It's designed for enterprise-level data processing, where you need millions of tiny interactions to happen instantly and for next to nothing.
So what's the big takeaway from all this? The real ambition here is for the blockchain to become a kind of universal utility, something as fundamental as electricity or the internet itself. It's about building a universal, unchangeable logbook for basically everything, from financial records and supply chains to voting systems and even the data that we use to train our AI. So I'll just leave you with this final question to think about. What kind of world could we actually build if every single digital action, every click, every data point, every tiny micropayment could be secured on-chain instantly for a fraction of a penny? That's the future this blueprint is really aiming for.